This week we're continuing to look at integration, but we're now working with substitution, and we also have a couple examples of definite integrals. So this first example, we let u equal 4x minus 1. We can take the derivative, which will be 4 dx. So we have the integral. I'm going to leave the 4x minus 1 as is. I want 4 dx at the end. So I'm going to need a 1/4 at the beginning. This gives me 1/4 times 4, which is dx, which is what we started with. But I want this 4 dx to match this so that I can replace it with du. And that's the next step. So we end up with 1 over u, and we end up with du. So this becomes 1/4 ln u plus c. Substitute back in, 1/4 ln 4x minus 1 plus c. Here's another example where we're going to use substitution. U equals x to the 4th plus 1. When we take the derivative of this, we get 4x cubed dx. Now, I know I want x to the 4th plus 1 to the 5th. And I need 4x cubed dx so that I can substitute for du. We already had the x cubed, but we didn't have the 4. So we're going to just go 15 divided by 4. So 15 divided by 4 times 4 gives us the 15 we started with. Again, I want this to match this so that we can replace it with du. So now we get 15/4 u to the 5th du, which is then 15 over 4 times u to the 6 over 6 plus c. Simplifying and subbing back in, we get 5/8 x to the 4th plus 1 to the 6 plus c. This next example is a definite integral. Now this is a very easy definite integral. So we're taking the integral from 1 to 16 of t to the 1/2 dt. This is the same as t to the 3/2 divided by 3/2, evaluated from 1 to 16. We can simplify that to 2/3 of the root of t cubed, evaluated from 1 to 16. So we have 2/3 times the root of 16 cubed minus 2/3 of the root of 1 to the 3rd. This calculates out to 42. This last example is a little more complicated. It's a definite integral and we have substitution. Okay, we're going to start by letting u equal x squared plus 2x. We can take the derivative, which is just 2x plus 2. I'm going to factor out a 2 just so it's easier to see that this is a multiple of the x plus 1 that's already in there, so that'll make our substitution easier. But we're also going to have to change our limits of our integral. So we know x equals 1 is the first limit, so this would give us 1 squared plus 2, allowing u to be 3. When x equals 2, the upper limit, we get u to equal 8. So now let's start substituting things in. So 1 to 2 of, I'm going to bring this denominator up to the -3. I know I need a 2x plus 1 dx at the end. So I'm going to need a half here because we introduced this 2. Again, we want this to match this, which means I introduce this 2, so I have to divide by 2 or times by a half. Now we can substitute in the u's, so 1/2 u to the -3 du, but this is where our limits of our integral change. Remember, these were x values. These have to be u values. Now we can integrate 1/2 u to the -2 divided by -2, evaluated from 3 to 8. Simplify. It's -1 over 4u squared from 3 to 8. We don't need to substitute back in because we have u values. We can just plug these into our calculator. So 1 over 4, 8 squared, minus -1 over 4, 3 squared, which ends up being 0.0239.